There we go. Okay, so good morning, everyone, and thanks for joining. I'm very happy to have the opportunity to tell you a little bit about what we envision to potentially become a problem during these stages of recovery and how to address it. So it's about what we call a post-COVID capacity crunch, what it is and how to basically solve it. A little bit about myself. As I mentioned, I'm Chief Customer Officer at Asaya, which means I'm involved in business development, but mainly focus on developing deep and valuable relationships with our existing customers to make sure that they extract the value from the products that we offer them and find new opportunities to create value together with them. Before I joined Asaya in 2018, I spent 8.5 years at Amsterdam Airport Schiphol in various roles, as you can see on the picture on the presentation here. Different roles: capacity management, airport development, operations, and eventually head of innovation is a little bit about my background. So first of all, I think everyone was taken by surprise by the spread of the COVID virus. I think everyone initially looked to China and thought back about the Sars outbreak, which was pretty much a local outbreak that only partially affected the aviation industry in the other parts of the world. And I think initially a similar response or similar situation was expected by everyone. And already airlines were sorry to reduce frequencies to Chinese areas, not knowing what was yet to come. And as the virus spread basically from China to Europe and then ultimately to the US, and I think even more recently to South America, obviously the most direct response is reduction in flights in order to contain the spreading of the virus. And I think the images you see in the presentation slide here very actively show, the impact, the sheer impact of just what that exactly means. Of course, less flights means less income, both for airlines as well as for airports as other aviation stakeholders. So currently everyone's going to cost savings initiatives, which again is an interesting thing to keep in mind, because once we go out of the crisis and traffic will resume, we have to look at what cost saving measures have been implemented, and will they have to be reversed, or if they actually made structural changes and lowered the operating costs in a structural way that allows them to be more profitable in the future. That's not the topic I want to address today. I want to look more towards capacity. Capacity within aviation was one of the main topics, I guess, together with sustainability going into this crisis. And it feels a bit weird talking about it right now. But the unintuitive truth actually is that as aviation starts to ramp back up, capacity might become an issue sooner than we expected at the moment. Because I think today, not a lot of people are worried about capacity bottlenecks. So on the slide, you can see 3 main areas of capacity bottlenecks, where they are today, or where we expect them to be soon, and where they were before we went into the crisis. And let's start with terminal capacity, which was not at the top of the list, but has now grown or climbed to the top of the list. And the main reason is that as airports implement all sorts of sanitary measures, social distancing, and those kinds of measures, the sort of space per passenger that an airport needs has increased a lot. And by that, the capacity, the number of passengers that the airport can actually process has decreased a lot. So I think from actually the ACI studies that were referenced before, some number between 20 and 40% of terminal capacity loss is anticipated due to the implementation of these sanitary measures. So that obviously immediately creates a major bottleneck, which puts it to the top of the list. If we then look at airside capacity, it remains currently in the 2nd place, and airspace capacity, it drops a bit to the 3rd place. And the reason for that drop is I guess obvious, because the amount of airspace, is the same as it was going into the crisis. There's just less aircraft now, and until we reach that point where there's as many flights as there were before, then we're back at the same place, which again is different than for terminal capacity, for example. Now, airside capacity is an interesting one, because you would expect that less flights also means less aircrafts at airside, which would mean there's actually more available capacity there. And this is actually where the unintuitive truth part sort of kicks in. And there are several reasons why this airside capacity will still be a problem, even though we have less flights. The first one is that there's a lot of parked aircrafts. So even though the flights are not happening, a lot of the stands at airports are actually occupied by flights that are not happening. Then the second thing is that as terminal capacity is less and as terminal processes take longer, it is expected that a lot of the processes around the turnaround related to the terminal, so mainly boarding, will take much longer than it took before the COVID crisis. Potentially because temperature checks have to be taken, potentially because of social distancing. So turnarounds are expected to take longer on the same amount of stands, which actually means you can do less turnarounds than you could do before with shorter turnaround times. So why is this airside capacity then actually important? First of all, if we look to the airlines, the available airside capacity is directly linked to the number of flights they can execute. And the number of flights they can execute, the frequencies they can fly, feeds into their schedules and basically to the profitability of the airline in the end of the day. And especially as we also expect that domestic and regional flights will start to pick up before international long-haul flights, and especially those domestic and short-haul flights are characterized by more low-cost operations with higher frequencies, with typically shorter turnaround times. The impact there is going to be much bigger, and airlines will not be able to fly the schedules they want to fly or need to fly in order to be profitable. So that's one of the reasons why this for airlines is crucial. The second thing, going back to the airports, is of course their revenues and profitability, because airports typically get paid aeronautical revenues and commercial revenues. So less flights means less income and less profit for airports as well. And even though some of that might be offset by longer parking fees if they've not been waived, it is far outweighed by the fact that there's less passengers and less commercial activity going on. The last point also is interesting to realize is, as the sanitation measures and as the measures under which airports are allowed to operate differ per region, also the impact on these turnaround times and airside capacity might be different per region. And I think that's one of the things also advocated widely, is that there needs to be some sort of synchronization, at least in Europe, but potentially even beyond Europe, in order to make sure that not one region can benefit from different measures being applied in other regions. So an unfair competition is potentially possible, which will in the end of the day affect the airline, but also the airport. So if capacity is a problem, the good thing is that capacity problems are not new to us, and we know to a certain extent how to deal with them. The fact is just that as flights increase, airside capacity will become a problem very quickly, even though it does not feel like it should. So how to address this problem is basically through optimization. So how can we best use the available resource, and how can we get the highest utilization of the assets and the resources that we have in order to process as many flights and to make sure that no flights that could be flown are actually not flown because of inefficiencies. And if we then look to optimization, there's basically two main components that determine the quality of an optimization. And the first one is the optimization model. So how do you choose to put what where? How you're laying the puzzle, basically. And then the second part is the input variables. Because even if you have the best optimization model, which can calculate the perfect outcome, if the input variables are off, if they're inaccurate or imprecise, then even the best optimization model will not perform. A term to refer to, or it's referred to with the term garbage in, garbage out. So let's look a little bit more at these two ways of getting the perfect optimization that will benefit airports and airlines as they ramp up their activities. And this mainly relates to stand allocation. In this instance, as we've seen that the number of stands could become problematic as turnarounds take longer and aircrafts are parked that are not flying. First of all, the optimization models. If you have a simple optimization model, it's a simple task, obviously, and it can be done very well by a human or by a simple computer program that is basically rule-based. Rule-based meaning, if this happens, then you do that. So it's very linear, very one-dimensional, and that works perfectly well. So there's no need to go into any more advanced tools than that. But typically, optimization in terms of stand allocation is a much more complex problem to solve. And the main reason for that there are so many input variables, different flights with different characteristics, different outcomes, because if you put a flight in one location, that might require a towing movement, or if you put it in another location, it will result in longer walking distances for your passengers. Or yet again, if you put it on another stand, it might require a busing operation. So the input variables are there's a lot of them, and on the other side, there's a lot of different outcomes that are impacted, and all of these are also, they intertwine with each other. So what we see is, like with other optimization problems, like a game of chess, computers have proven to be better at that. Especially artificial intelligence has proven to beat humans over and over again in these kind of complex optimizations. The second and last part that I want to talk about is the input variables, because even if you have the perfect optimization model, it all depends on how accurate are our input variables in order to come to the best outcome. In this instance, I want to focus specifically on the off-block time, because the off-block time of an aircraft determines when is the aircraft introduced into the system and is the stand available for another flight. Today, what we see is that the data point available as an input into these optimizations is the target off-block time, which is put in by the ground handler. And no offense to any ground handler companies or employees, because these people, they have a ton of activities around the aircraft turnaround, and they're spread thin as their margins are also thin. So we see in practice that the target off-block time is typically updated either very late into the process, or not updated at all, or updated inaccurately, which result in inaccurate input data for these optimization problems. Now, by using existing data, or by using, for example, computer vision to capture real-time turnaround data, you can actually create a predicted off-block time that is far more accurate and is automated. So it takes away some of the strain on these people that are already very busy, but at the same time, you have an automated, more accurate data source that will then feed into the optimization processes that you already have and sort of almost automatically improve the outcomes that you have there. So thanks a lot for your time again. If there's any questions later on, I'd be more than happy to take them. And hereby I'd like to hand the floor over to the next speaker.
Thank you, Christian.